All right, well, I'm Joanne Garlow. I work for National Public Radio on their website. I'm one of the lead developers. I had a lot of experience in Oracle, and this fall we migrated over to MySQL. So I'm sort of tailoring this talk to people who might have a lot of experience with Oracle, but maybe not so much with MySQL. And talk about some of the things that we encountered, the problems and how we resolved them, and some of the tools that we use and some of the things that helped us. I'm going to just go quickly over the background of who I work for, what we do, our database architecture, and how we decided on how to break up our database and how we did replication. So hopefully some of the decision process that we went through will help you if you're doing this as well. We're talking about the SQL differences between Oracle and MySQL, particularly with functions and some of the different ways that parts of it work. Concurrency issues that we encountered and what we did, especially some of the tools we used to help us figure out what the problem was and how we resolved it. And then finally, we did some switching between our encoding schemes, and so sort of some of the things that caught us in that. First, our background. I work with National Public Radio, so we are both a producer and a distributor of audio content. Things like, if you ever listen to All Things Considered, Morning Edition, Wait, Wait, Don't Tell Me, Fresh Air, different shows like that. They're broadcast over about 800 local radio stations. So we have a relationship where we have a national headquarters, and then there's stations all over the country that both give us content and use our content. Why are we interested in the database? If we're a radio company, it's because we also have a website, npr.org, that has over 10 years of archived audio content from our radio programs, as well as different materials that we produced ourselves just for the web only, including blogs. We have great slideshows with some terrific pictures, and editorial columns, as well as a great music site where you can get music that's it's just some really interesting sort of alternative music. We're very big into podcasting, got into that fairly early, and we're one of the larger with our own podcast, as well as a directory of podcasts from member stations. We are involved in mobile applications and mobile websites, and we do syndication through an open API, where if you ever want to use any of our content, this is open source, also open data. You can come and use our content and put it on your site. Our system architecture is, our main database is, I'm supposed to be walking around, I'm not very good at that. I'm not walking around. Our normalized database is there. It comes off a content management system that we wrote ourselves, a homegrown system. We have a number of different inputs, including inputs from station data, from the public website, and as well as editorial content. In order to isolate our database before, and this is what, when we had Oracle, we had already put in a couple different layers that sort of isolated our content from our presentation layer, including a flattened database and an XML repository, which is just a series of XML files that hold specific amounts of data about different pages or different resources in our system. We memcache that layer, and then we also have an API layer that, as I mentioned before, this open API is available to the public, but we also use it internally in some of our systems and then across member stations. And that API layer also does a set of queries, as well as using the XML repository, and that is also memcached. And then comes out to our presentation layer, and then just a way of separating our content from a way we present it. And that includes things like stations will put our content directly on their system, our mobile apps, our website, as well as some widgets and mashups that other people have done in the public. We were reaching the limit of our Oracle architecture, and we didn't have enough budget, nothing like working like at a nonprofit during a recession to make you think about your budget and everything you do. We were starting to get, our database was overloaded. It was a single point of failure. Even with our caching and our the different layers that we had put to kind of protect it, it was still causing problems. And we really couldn't afford multiple servers for an Oracle implementation.
So can I ask a question?
Please, ask questions.
You just said the database was crashing frequently.
Yes.
Can you extrapolate, like, was there a problem?
Yeah, we were basically having, once the connections just started increasing, then it started to slow down, you hit deadlock situations, and just everybody was waiting for everybody else. So it was really just maxing out.
So it was really a throughput sort of blockage, so we just became unresponsive.
Exactly. Exactly, and it would go exponential, so it would be fine, 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 and then we'd have some very popular story and it would go through the roof. Go ahead.
What version of Oracle?
I'm sorry, I didn't hear you.
The version of Oracle?
We were using 9i. So we decided to take this opportunity to think a little bit more about being able to use MySQL allowed us to do more redundancy and think about scalability in a different way than we had with Oracle. It just gave us a lot more flexibility in creating new databases and master-slave configurations. We wanted to do more load balancing across our web servers and the different we can divide some of our content in the way that it's, like the API calls versus the website calls versus some of the station calls. So just kind of thinking about that in terms of balancing. We also wanted to separate concerns. One of our issues was we had, both public data as well as sort of our own private editorially controlled data kind of in the same database. So we wanted to sort of separate things out a little bit according to how it was being used. And also to provide us a little level of security by having the read-only databases being what's accessed directly by the website. Again, in this high-level architecture that I showed you earlier, what we're focusing on is that highly normalized database there that's attached to the content management system. That's what we're going to be talking about next, and sort of the architecture of that piece. I want to show it in context. So this was the database architecture that we eventually ended up with. I'm going to go through it piece by piece. Our first part is kind of the most obvious part. It's our main database. This is what is updated by our content management system. It's very transaction oriented with transactions updating sometimes 15 tables in one shot. It's a lot of resource contention. We have multiple editors all editing the same kinds of stories at the same time. And highly normalized, so there's a lot of foreign keys, a lot of worrying about keeping it all in sync. So we of course went with InnoDB database. We're not using the plugin yet, but we're hoping to move to it soon. And this is the main database of the website itself. This is the database. Because of that, that's the one we wanted most to keep isolated from the main website, so we created the read-only slaves that come off of it. The website only accesses those read-only slaves. And this makes it more horizontally scalable. As our website grows, as we have different needs, we can then add new slaves on this. Right now, our main database is not having any problem keeping up with our reads. Once we've figured out some deadlock issues I'll talk about a little later. We also had a database that our content management system was using that was pulling in music data from the AMG. This is an entirely different set of tables that are updated only by a nightly script. They're mostly used as lookups for information about songs and artists and albums, information like that. It's read-only by our content management system. The main requirements for this database, though, is that the lookups needed to be very fast. We were using Oracle text queries in our Oracle system, and now we needed the full text queries here. Also very large tables. So for this database, we're using MyISAM. And we have found actually that worked very well. We didn't really have any problems. We thought this might be an area where we were really going to have to spend a lot of time, and it turns out it was fast enough kind of first shot, so that was good news for us. We also had a public database, so these are tables that are written to by our website only and read from by our website for things like user registration, registering for newsletters, information like that we keep about our users ourselves. So these are mostly small tables, small transactions, sometimes they're log tables, but they're really low resource contention. People are not registering in large quantities all the time. So we're still using InnoDB just because it's easy, but this is a much smaller database. We were able to put it on a different server and allow it to kind of not interfere with the main content management system. We also have a stations database. This is, again, updated infrequently. It's kind of lookup data about the member stations that we're associated with. It's a quarterly script. It's mostly read-only. It's not used by our content management system. Low resource contention, some log tables, but other than that, it's really that's not transactional. Again, we just went with InnoDB because it's easy, it works, did the job. It's kind of all we needed. And then for these databases, because these two are not something that we really, there's not a lot of contention on them. I mean, there's not a lot of load on them. We were able to use a backup really just as, the slave is just a backup. It's not really used anywhere. It's just in case we need to do a hot backup of those two. Okay, so that was our database architecture. We got that in place first. We figured that out, started setting that up on our test servers, and then we started to convert our SQL. We were fairly lucky. We had done a pretty good job of isolating our database layer from the rest of the system, so we really only had to change. We have our content management systems written in Java on Tomcat, and we had to rewrite just one package in there, and then even on the PHP side, which is our front-end system for our website pages, and again, we had kept all our database in sort of one directory, so it was easy to update. We did hit a number of issues. One is that MySQL is case sensitive. Again, we were lucky that we had a coding standard to keep all our tables and our columns in lowercase. But, so that saved us a lot of work there, but that's something to think about if you are converting your own system, if you've been consistent about how you use capitalization for your tables. Although we did use the outer join syntax of the plus sign for Oracle quite a bit, and we had to go through and change all of those to outer join clauses. That took a fair amount of time of reworking those queries. One of the things that was a kind of a gotcha is that in some places in the code, Oracle will return a 0 if you try to do an update and you update 0 rows. But MySQL will return a 1 saying you successfully updated 0 rows. So it's just something that we had to kind of keep track of. If you have places in your code that you're checking that, you might want to just keep that in mind as you do your conversion. Also, MySQL will sort nulls to the top while Oracle sorts them to the bottom. You have a workaround for this. If you need that functionality to work the same way in your system as you convert over, if you use an order by with a negative and sort descending, it'll be the same way that you would do an ascending query, ascending sort in Oracle with the nulls at the bottom. One of the things that we really were happy about was the limit clause in Oracle. You have to use the, where you do the subquery and use a row num, and then say in an outer query where row num is minus, less than 10 or whatever you want. Now we have a limit clause, so we got to rewrite a lot of our queries and make them a lot simpler for MySQL, so that was a good thing. But our system did depend heavily on the fact that we used a sequence to generate a unique ID that would be unique across all the tables in our system. We weren't able to use auto-increment because, again, it had to be unique across all tables. So we do have a workaround for replacing Oracle sequences. One is you just create a table with a single row that's your ID, and that single row then becomes your way of incrementing your sequence, and then you can use this last insert ID. And do the select on the last insert ID. You have to do it this way to make sure that the ID that you get back in your select, that second select, is the ID that you incremented and not the person who incremented it after you. Because we use this sequence so much that there's a lot of contention on it. We also had to make sure we kept those out of transactions. We kept those out of transactions so that we wouldn't have it deadlocking and holding that table. Another place that we needed the Oracle sequences, we had some issues, is when we were doing an update where we were updating, say, 25 or 100 rows at one time, and we wanted to use a unique identifier for every single row we were doing an insert of. So for this one, we found this workaround on the web where you figure out the number of rows that you need total, and then you increment your sequence by that number of rows. And then you use and I don't know, you store that into a variable. I don't know if when we started using MySQL, we started using variables in our SQL. And so you can use a variable of the last sequence, and then you use a fake row num where you set the row num to be 1, and then you keep subtracting from it for every select. And this will allow you to sort of fake out getting a sequence number from when you're updating a number of rows at one time. These slides will be available so you guys can grab a copy. Another area that took us a little while was converting functions. We ended up creating sort of a cheat sheet where we all could go and look as we started rewriting some of our queries. For null-val in Oracle, you can use if null or coalesce in MySQL. Depends on whether you're just converting the null-val to one particular value, or if you have multiple values, it could be. Decode, again, using case or if statements is sort of the equivalent in MySQL. Concatenating. When you're concatenating in Oracle, you can use the two things, the two pipes, and concat works the same way in MySQL except for null values. If you're concatenating a null value, there's a difference between the way Oracle and MySQL works. So you have to use, for MySQL, you have to use something like a null, if null, you can say use an empty string. That work the same way. There's no left trim and right trim in MySQL, but there is a trim, so you can usually get around whatever you need to do there. It's not too bad. One of the ones that was kind of difficult to figure out is in-string works differently. So both MySQL and Oracle have in-string, but they don't work the same way. And actually, we ended up replacing the Oracle's in-string with locate, or in some cases, with reverse or substring index, depending on what we were trying to do, depending on how complicated the searching we were trying to do was. Dates. It's easy to find this one, sysdate. You get an error in MySQL, so you can easily find them if you miss a step and replace it with now. But a harder one to find was when you're adding and subtracting dates. In Oracle, if you do a -1, it subtracts a day. But if you do it in MySQL, it subtracts a millisecond. So you're not going to get an error, you're not going to get notified, queries are not going to work because they're going to be looking for things within a millisecond of time. The workaround is to use interval. You have to go through, find these, and use interval. That was kind of a pain because it's hard to find -1 in my code base. It's not easy to do a search and replace for. Truncate, you just use date, and toDate and toChar, we use string to date and date format. The formatting strings are different between MySQL and Oracle, but they're not that hard to figure out. It's not hard to convert. There's differences in the way update works. In Oracle, you can't update a table. I'm sorry, in MySQL, you can't update a table that is used in a where clause in a subselect. But in Oracle, it's the other way around. You can't join in an update statement in Oracle. So it's one of the differences. We use this kind of statement all the time, where we either have a where our column was in a second table, or we would use an exist, where exists something in a second table. But the nice thing is actually the MySQL is much easier because you can just do the join and then just update the one table. So I found MySQL to be much easier, but we did have to rewrite that code. I'm not sure how many people use rank and dense rank. This is an ability to sort of sort within, so you're doing a SQL that's taking a whole bunch of rows, and then within each row you're taking just the top few values for some result instead of getting all of them. The example that we have here is when we're getting the information about the artists that are associated with an album, AMG data gives us like 20 artists, and we just don't care about the 20 artists, we just want the top 2 artists or whatever from that album. So what we would do is we were using rank and dense rank for that, but there's really no good MySQL equivalent, so we couldn't find anything. What we ended up doing was we ended up using a group concat, so with an order by and a group by. So we had a subselect with an order by and a group by that concatenated all the list of artist names for a particular album, and then we could take that one column and pick the top 2 out of it, which isn't really a great workaround, but if you get stuck, you could try looking at those functions and see if that helps. Okay, so I've talked a little bit about how we figured out our database architecture, and I talked a little bit about the differences between MySQL. Now I'm going to talk about some higher level issues that we encountered, maybe help you guys from hitting the same ones. One of them was collation. You can set correlation at the server, database, table, or column level in MySQL. And what I suggest is that you all take a second before you do anything and make sure you get it right at the server level, because if you don't get it right at the server level, which we didn't, and we didn't know until much later, then it's really kind of a pain. What ends up happening is that once you change it at the higher level, anything you created before that won't get the change. And so, any pre-existing. And so then you have to go through on those and specify the correct correlation on the ones that are pre-existing. And then you think you have it right, and you find out that the backups will still go back to the original correlation unless you get it right exactly at the column level. So I suggest getting it right, rather than doing what we did, which was figure it out 2 months later that you didn't get the correlation right. Okay, so we finally got our system, we got our database set up, we had our SQL rewritten, and we got everybody together to start doing some concurrency testing. And the first test we did basically came to complete halt, deadlocks everywhere, complete slow queries, and you know, it was really a tough moment when you realize that you're not sure what you did wrong. We looked at our MySQL configuration because we thought that we had sized things correctly and we had gotten stuff close enough that we shouldn't have had this many problems. But we were doing a lot of very safe things, syncing to disk and doing write with every commit. And in addition, we had set our transaction level to read committed because that's the same thing that Oracle does, and we didn't want to find any subtle differences in the way it works in our system, in our content management system. But we wanted to keep these, so we were trying to figure out if there was something else we could do. Some of the tools we used, I know Top turned out to be helpful. I haven't had too many people talk about this one so far.
I love it.
What?
I love that tool.
Yeah, it's a great tool. It really helped us to identify the deadlocks and the slow queries. I mean, we were obviously looking at the slow query log as well, but this helped us figure out at the point where everything just ground to a halt what was going on. And we also used the show engine. I know status with the /G like saved me from going crazy trying to figure out what these things meant. So that's also good for contention and locking issues, some good ways to follow through. We do use the enterprise monitor. We did follow some queries with that, and we could, obviously follow the connections and things using the enterprise monitor. We use the query browser, the MySQL query browser. I've been using Oracle SQL Developer for so long, it's kind of hard to switch over, but that's helpful. It's very similar. Displaying plans a little different. The MySQL Administrator was also a good way to watch the connections, because if you look at the Connections tab in MySQL Administrator, it will tell you what query it's sitting on and how long it's been waiting. So you can start to see also there a place where you can kind of keep track of where the contentions are coming up.
There's also MyTop.
MyTop. Okay.
It's a command line tool like Top in Unix, and it does exactly that. It shows the connections that are connected and what they're doing.
Okay. Great. We also tried using the query profiler. I put the link here so you could read more about that. We did not find that as helpful, but I think that may have just been because our problem was elsewhere. So that was something we could use for debugging slow queries. In the end, tuning the SQL, looking at our server configuration all helped, but I thought this was fun that that we're not the only people who have found this. It turned out to be a hardware problem. That we had a RAID card that actually just didn't have a write cache, and it was just, we replaced the RAID card problem right away. So all the tools in the world for MySQL can only help you so much if it turns out your hardware is not right. So keep that in mind as you're trying to solve problems, that just sometimes you just got to go back to what's going on here. All right, a couple encoding gotchas. So we were using this opportunity to switch from ISO 8859-1 to UTF-8, and because our website is UTF-8, but we had only done that after we had set up Oracle, and we didn't want to make the change inside Oracle, which is too much work for not enough gain. Actually, we found that the migration tool was very helpful. This is the MySQL migration tool, was very helpful with this. It really handled the write cases. Where it didn't handle very well is with characters that actually just weren't encoded correctly in the Oracle database. So they were just wrong before, and it just messed them up even worse. So one of the things we had to do, and I don't know if you guys have looked at the migration tool at all, but there's a migration GUI, and that helps you get everything sort of set up and what you want to do in the migration. And it produces a Lua script that then acts as sort of a configuration for an actual script that actually does the migration, the Java code that actually does the migration. And there's very little documentation for that Lua script, and that was sort of what had to be modified in order to get these weird characters that, you know, were kind of bad anyway, kind of get them fixed. It also, the main guy who was doing this, the developer who was doing this, he said that after he used the migration tool a couple times, he sort of stopped using the migration tool and he learned enough about Lua to just modify it by hand. So that's one of the problems that you might come into. The other issue that we had when encoding, working on this encoding and changing the encoding was that you really have to think about it, the whole system end to end when you're doing encoding. Our first focus was making sure that the data got correctly stored as UTF-8 in the database, in the MySQL database. But it turns out that you really have to kind of check every level. Every JSP page had to change, because you have to set a variable at the top to tell what the coding is at the JSP level. Our Perl scripts, we have different Perl libraries on our different servers, because we have main servers, we have our web servers, we have our development servers, and we have our test servers. And so getting those all to have the right libraries and have the correct Perl stuff set up on them was kind of a nightmare. And the PHP had some changes, and then as well, when the Tomcat, there were some server configurations in the Tomcat to get the Java to make sure it was handling everything correctly in UTF-8. So that was probably our biggest gotcha there, was just not, when we took on that task, we were focused on too small an area, and we needed to focus at a larger level. We have one issue that we continue to deal with, and this is one of the reasons we're looking at going into the InodeDB plugin as opposed to the way we're using it now, is that there's an inode locking, that will lock specific records as opposed to gaps before records. For those of you who know the details of how databases work, it's basically, it's uncommitted but timed out transactions. And there's really, what will happen is you go into any, either on top or any other way that you want to look at the different locking threads. These threads are blocked because they're waiting for a lock, but there's no lock holding a lock. And there's nothing you can do about this except reboot MySQL. It doesn't happen so often for us that it's a real problem, but we will sometimes have to reboot MySQL in the middle of the day.
You noticed you said before you used read committed. Are you still using read committed?
Yes, all of those values we kept.
Right, okay. And read committed in Oracle is not the same as read committed in MySQL. It's actually, the use of the word is misleading. It's actually repeatable read as opposed to representation. So that gap blocking issue may be because of read committed.
Oh, really? Okay.
We can talk more afterwards.
Yeah, that would be interesting. Okay, good. So that's it. That's my presentation. Those are some of the things we encountered. If I didn't talk about something that you might be interested in, you can ask me, because it's most likely that we didn't hit a problem with it. Some things went quite smoothly. We actually had our deadline moved up 2 weeks because the Oracle database was crashing. They said we need to go live 2 weeks earlier than we were expecting, and they did the thing, you know, where bosses do, where they throw 3 more people on the project. Like, having more people helps at that point when you're when you have your deadline totally changed. But it worked out fairly well. Most things went fairly smoothly, and it was just kind of a matter of getting everything right, and making sure that you've done kind of your checks of everything. So, you have any questions? Does anyone? Go ahead. Go ahead.
How large was your database and the application?
I'm sorry. How what?
How big was your application?
How big was the application?
The data set.
You know, I don't know that I can answer that off the top of my head. I mean, we have, yeah, I can't answer off the top of my head, I'm sorry. I'm not a DBA, so I didn't do the sizing. Somebody else did the sizing. I can find out, and if you want to email me, I'll send you the information, but I don't know it off the top of my head.
And how much time did it take for the whole project?
We started out by migrating just those 3 smaller databases, the ones that were kind of in this corner in that picture, and that took about a month and just a couple developers. It really didn't take that long. And then we did the bigger one. We brought on a couple more people. We probably had 5 developers working on it, and it took us about another month. So it wasn't very long at all. The whole project was pretty quick.
With all the annual changes to like SQL queries and things, what do you do to validate that they were working? Do you have like unit tests in place to test they were still returning the same types of results, or how do you approach that?
Yeah, well, we did not before this have the unit tests, and we did after. We you know, that was nothing encourages you to write them like that. In some cases, we just use test cases. In most cases, the MySQL will literally just fail if it's not written right, if you forgot to change one. So that did make it a little easier. I tried to bring up a few cases where that is not true, like the subtracting one day one. But really it was a matter of just going through and testing our system. We really aren't that good about having a lot of unit tests because our schedules tend to be really tight, and we really only have about 6 developers. I'm sure all of you are nodding as I say that. So it's hard to get everything done.
So the primary reason for doing this is the cost of buying more Oracle licenses and newer hardware was prohibitive.
Yes.
Correct? Which is the primary reason why people migrate away. At the end of the result, did you sort of calculate that, like for example, that upgrade was going to cost, say, $120,000 in software licensing, and still only gives us one server, and the time that it cost us to redevelop and the loss of time of that? Did someone actually, did you come up with a rough idea? I mean, I know you look at just the license cost, but did someone actually evaluate, the cost that it actually took from your business? And the biggest thing also, people also don't calculate is you have to go through that reskilling process of now, using MySQL. I'm just wondering whether at the end of the day you said, was there something more that was worth it other than just the license cost?
We did not do that calculation. No, it's a good point. Most of the people on our staff were much more Oracle people. So there was a little bit of that relearning, but we did bring on a bunch of new developers around the same time who were mostly MySQL focused, and we would have had to train them in Oracle. So it kind of balanced things out, but it would have been a good exercise to kind of figure that out on the amount of time we spent. But it wasn't that hard.
This is good as a confirmation because clients that I deal with are like that now. They're moving because it's going to cost them $1.5 million to buy hardware and rack and Oracle licenses, and they're going, well, how much is it going to cost me to redevelop?
Right.
So,
for us, it was clearly a win, to go to MySQL. It just gives us so much more flexibility and so much more growth. That the growth possibilities are so much easier. And we're growing rapidly, so it's a good thing. Yes.
Did you use a lot of Oracle search functionality when you were on Oracle that you had to give up the MySQL?
Oracle search.
Yeah, Oracle text functions.
The Oracle text we did. That was when we were doing the AMG data, the music data, and it really using the MyISAM database was really, really easy. It was one of those things that we had set aside a lot of time to do and for prototyping, and the first prototype just worked well enough. So we were very happy with that. Any other questions? Go ahead.
When did you do this?
We started last August and we finished at the beginning of November.
Did you get any, are you an enterprise customer of MySQL? Did you get support from them?
We did, and it was helpful near the end there when we were having the problem with the concurrency. We did. They still give us some advice on slower queries that we're working on, and they've been giving us suggestions. The person who works mostly with them was our DBA, and I'm going to throw out his name, Shane Miley. I promised him I would. He solved a lot of the problems. He was the one who figured out the problem with the write cache. So you really got to give them credit when they can figure those kinds of things out. It's just out of left field.
How much Oracle expertise did you encounter with the people you worked with?
Say that again?
How much Oracle expertise did they have that you were working with? Were you having to teach them a lot about what you were doing in Oracle, or were they pretty well up to speed?
No, I don't think that was the case at all. We did have we still had we had a IPsoft, which is a Oracle. They're actually database people, and they do Oracle and MySQL. So if there was a question about the conversion, we could ask them. But we honestly, searching the Google was usually just as fast. So we didn't have that problem. Anything else? Thank you very much. I appreciate your time.